If you have ever looked at a string and thought, I know the answer is hiding in here somewhere. I just need to find every place it shows up. This episode is for you. LeetCode 438. Find all anagrams in a string. This is our string S, 10 characters. C, B, A, E, B, A, B, A, C, D. And this is P, A, B, C, 3 characters. How many times does an anagram of A, B, C, same letters, any order, appear inside S? Twice. CBA at index 0, rearrangement of ABC. BAC at index 6, also a rearrangement. Fixed window, character frequency match. Store every matching index. Those 3 things. That's all this problem is. Output is 0 and 6. And if you have watched episode 5, Permutation in String, you already know 95% of how to solve this. The remaining 5% is one line of code. We will get to it. Let's go. Before we dive in, let's just take 30 seconds to zoom out. Episode 1, what is a window? Episode 2, fixed size window, maximum subarray. Episode 3, variable size window, longest substring without repeats. Episode 4, minimum window substring, the hard one, the flagship problem. Episode 5, permutation in string, fixed window, character counts, true or false. All done. Today is episode 6, find all anagrams in a string. And just so you know where we are headed, episode 7 and 8 are going to introduce a new trick we have not seen yet. A variable window with a max frequency constraint. But that's next time. Right now, episode 6. Let's get into it. Here is the problem statement. Let me read it to you exactly as LeetCode gives it. Given two strings S and P, return an array of all the start indices of P's anagram in S. Simple enough on the surface. But let's make sure we all agree on one word before we go any further. What is an anagram? An anagram uses exactly the same characters with the same frequencies, just in a different order. So S is CBA, EBA, BACD. P is ABC. Window size is length of P, which is 3. We are looking for every position in S where a 3-character window contains exactly 1A, 1B and 1C in any order. CBA at index 0, 1C, 1B, 1A. That's a match. And BAC at index 6, 1B, 1A and 1C. Also a match. So output is 0 and 6. Second example, S is ABAB, P is AB. Window size is 2. AB at 0 match. BA at 1 match. AB at 2 match. Output 0, 1, 2. Constraints, strings up to 30,000 characters, lowercase only. And notice something, the problem is quietly telling you right here. The window size is always fixed at length of P. It never changes. That one observation is going to drive the entire solution. Okay, I have to be honest with you. When I first saw the problem after episode 5, my immediate reaction was, have not we already done this? And the answer is almost. Let me show you exactly what I mean. Episode 5, Permutation in String, LeetCode 567. The question was, does P have a permutation somewhere in S? The approach, fixed window of size length of P. Slide it, compare frequency maps, return true or false. Episode 6, Find all anagrams, LeetCode 438. The question is, find all positions where P is an anagram in S. The approach, fixed window of size length of P. Slide it, Compare frequency maps. Collect the starting index every time you match. Episode 5 asked, does it exist? You found it. You returned true. You stopped. Episode 6 asks, where does it exist and how many times? You find it, you record it, and you keep going. Same template, same logic. The only difference, instead of stopping at the first match, we keep going and collect every match. If you understand episode 5 and you are here, so you did, then you already understand 95% of today's problem. The remaining 5%, one line of code. We will get there. Before we look at any code, I want to make sure the core idea is completely clear. Two strings are anagrams if and only if their character frequency maps are equal. That's it. That's the whole mathematical foundation of this problem. What does that mean in practice? P is ABC. So P's frequency map is C with one count, B with one count and A with one count. Now I slide a window of size 3 across S. First window CBA. C with one count, B with one count and A with one count. So that equals P's frequency map. There is a match. Add index 0 to results. Slide right by 1. New window BAE. B with one count, A with one count and E with one count. That does not equal P's frequency map. C is missing. E is extra. Skip. And you do this for every window, every single slide. One comparison per step. That's the algorithm. Check the frequency map after every slide. Collect the start index every time they are equal. It sounds almost too simple, but that's what O of N solution looks like. They find the right question to ask and ask it efficiently. Let's walk through the full example so there are zero gaps. S is CBAE, BABACD. P is ABC. We expect output 0, 6. I am going to go through all 8 windows. For each one, the window, the frequency map, the comparison and what happens to the result. Window 0 to 2, CBA, frequency map, A with one count, B with one count and C with one count. And P frequency map, A with one count, B with one count and C with one count. They match. Result becomes list with 0. We slide right. We added E, we dropped C. Map is now B with one count, A with one count and E with one count. C is missing. E does not belong. No match. Result stays at list with 0. Window 2 to 4. AEB. Also no match. Window 3 to 5. EBA. No match. Window 4 to 6. BAB. B appears twice now. Frequency map is wrong. No match. Window 5 to 7. ABA. A appears twice. No match. Window 6 to 8. BAC. B with one count, A with one count and C with one count. B frequency map, A with one count, B with one count and C with one count. Match. Result becomes 0 and 6. Last window ACD. A with one count, C with one count and D with one count. B has no D, so no match. Final result stays 0 and 6. 8 windows, 2 matches, 1 pass. Alright, we have walked through every window by hand. We know what the answer looks like. We know why it works. Now let's actually code it. I am going to switch over to LeetCode. Problem 438. Find all anagrams in a string and we will write the solution live. I will type it out step by step. No copy paste. No shortcuts. If you want to follow along and try it yourself first, pause here. Come back when you are ready. Problem 438. You know what we are solving. One thing worth noticing, S can be up to 30,000 characters long. That rules out any nested loop approach. We need O of n. One pass, no going back, which is exactly what we have. Let's write it. First line, import counter. Counter is not available by default on LeetCode. Always add this at the top. Otherwise, you will get a name error on submission. Now, inside the function, build both frequency maps. Pcount is equal to counter of P. This is our reference, the character frequencies of P. It never changes. And now wcount, this is our first window, the first length of P characters of S. Now result is the list we will return. Before the loop, check window 0 separately. If the maps already match, at this point, index 0 is the answer. We handle this before the loop because the loop starts at index length of P. It assumes window 0 already exists. Now the slide. For every new character coming in on the right, increment. The character leaving on the left, decrement. And this line, delete the key if its count hits 0. This is the one detail that trips people up in interviews. Counter equality in Python checks both keys and values. A key sitting at 0 is not the same as missing key. They will not compare as equal. Delete it. Keep the map honest. Now, after every slide, compare. Maps equal. The current window is an anagram. Append the start index. Now return the result. That's it. Clean. Let's run it. All test cases pass. Submit. Accepted. Runtime O of n space O of 1. Good. The code works. We have seen it pass. But I want to make sure the why behind every line is completely clear. Not just that it works, but why it has to be written exactly this way. Back to the slides. Let's walk through it step by step. The code is written. It passes. You have seen it run. But I want to go back through it deliberately because when you are in an interview and someone asks, walk me through your approach, you should not be reciting code. You should be explaining decisions. 5 decisions were made in that solution. Let me show you what they were and why each one had to be made exactly that way. Decision 1. Build both frequency maps before the loop. We count P once. It never changes. We count the first window of S once. That's our starting point. This is setup you do outside the loop, not inside. If you rebuild this on every iteration, you are back to O n cross k, exactly the nested loop we were trying to avoid. Decision 2. Check window 0 before the loop starts. The loop begins at index length of P. It processes every window after the first one. If you don't check window 0 before entering the loop, you miss it entirely. This catches the edge case where S and P are the same length. Only one window exists and it's window 0. Decision 3. One in and one out. Never rebuild. One character enters on the right. One leaves on the left. The map stays live. This is what keeps it O of n. Each slide is O of 1. One increment, one decrement, and a delete if the count hits 0. 3 operations at most. No nested loops. No matter how long S is. Decision 4. Compare after every single slide. After every slide, one comparison. Maps equal, append the start index. Not sometimes, not when you feel like it. Every step. That's how you guarantee you don't miss any match. Decision 5. Return the full list. Not true or false. Not just the first match. The complete list of every starting index where a match was found. That's the one thing that makes this episode 6 and not episode 5. Time complexity O of n. One pass through S. Every slide is O of 1. No nested loops, no rebuilding. Space complexity is O of 1. The frequency maps hold at most 26 keys, lowercase letters only. Constant, does not grow with input size. 5 decisions, O of n time, O of 1 space. Now let's look at the code one more time, line by line. You have already seen this code pass on LeetCode. Now I want to go through each section and connect it back to the 5 decisions we just discussed. So every line makes sense, not just works. Same solution, let's annotate it. From collections import counter. Counter gives us frequency maps in one line. Without this import, on LeetCode or anywhere, you will get a name error, always at the top. Decision 1. P count equals counter P, built once, never touched again. W count, counter of S from start to length of P, the first window before we slide anywhere, and the result starts empty. We fill it as we go. Decision 2. Window 0 checked before the loop. If it matches right now, 0 is already an answer. Miss this slide and you miss the case where the answer is a list with 0 index. Decision 3 and the detail everyone forgets. W counts of S of I incremented by 1, so write characters in, and W count of left is decremented by 1, so left character out. And then this, if W count left equals 0, we delete that key. We covered this on LeetCode, but it's worth saying again here. Counter equality checks keys and values. A key at 0 is not the same as no key. If you don't delete it, your comparison will fail even when the window is a valid anagram. This line is the difference between a solution that almost works and one that always works. Decision 4. After every slide, compare. Match. The window start index is I minus length of P plus 1. Append it. Decision 5. Return result. The full list. Every index, not just the first index. Same 16 lines, but now you know why every single one of them is there. The counter solution works. But here is a question worth knowing for interviews. Our strings only use lowercase letters, A through Z, 26 characters, nothing else. So why use a dictionary which can hold anything when we already know there will never be more than 26 keys? We don't need to. A plain integer array of size 26 does the same job with less overhead. Same logic as before. Instead of counter, two arrays of 26 zeros, PARR and WARR. One slot per letter. The slide, the increment, the decrement, the comparison, identical to the counter version. You are just comparing two lists instead of two dictionaries. But how do you map a character to its array index? One formula, ORD of CH minus ORD of A. Look at the table. ORD gives you the ASCII number of a character. A is 97, B is 98, C is 99 and so on. Subtract 97 and you land at 0, 1 and 2 and so on. You don't need to memorize ASCII numbers. Just remember the formula. The subtraction always gives you the position of that letter starting from 0. And notice no delete step. With counter, we had to delete keys at 0 to keep the equality check honest. With arrays, 0 is just 0. Index 0 always exists. The comparison works automatically. Now, is this actually faster than counter? The honest answer, technically yes. Practically, maybe. Counter comparison hashes keys. Array comparison reads integers directly. No hashing, no key lookup. Same O of 26 per step, but arrays are lower level, tighter memory, less overhead per operation. Here is what I would tell you in an interview. Write counter first. Readable, correct, shows you know the standard library. Then, if they ask, can you optimize further? You pull out the array version. That's the moment it earns its place. Two tools, same problem. Know when to use each. 4 edge cases. These are the ones that catch people in interviews. First, P is longer than S. S is AB, P is ABC. Window size would be 3, but S only has 2 characters. No valid window can exist. Index till length of P just gives you all of S. The first window check fails. The loop range length of P till length of S runs 0 times. Result is empty list. The code handles this automatically. You don't need a special case, but you need to know why it's handled so you can explain it confidently. Second, S equals P exactly. S is ABC, P is ABC. One window covers the whole string. Frequency maps match on the first check. Output is list with 0 index. Third, all characters are the same. S is AAAA, P is AA. Window size is 2. Every window is AA. Every window matches. Output 0, 1, 2. The key here is correct counting. P count is A with 2 count. Each window's W count also needs to be A with 2 count. If your decrement and delete logic is right, this works automatically. Fourth, no anagram exists anywhere. S is XYZ, P is AB. The maps never match. Result stays empty. Return empty list. No surprises there, but it's worth saying out loud so your brain registers it as a valid path through the code. Okay, this is the consolidation moment. I want you to walk away from this video with 4 things locked in your head. 1. The window size is always fixed. Length of P, always. Every slide is 1 in, 1 out. The window never shrinks, never grows. 2. The check is a frequency comparison. If win frequency equals P frequency, the current window is an anagram. One comparison per slide. 3. Collect every match. Don't just check for one. Episode 5 returns true at the first match. Episode 6 records the index and keeps going. That's the whole difference. 4. Clean up 0 counts. When a character's count drops to 0, delete it. Python's counter equality is exact. A key with value 0 will break the comparison. Same template as episode 5. The only new line is result.append I minus length of P plus 1. That's the 5% I promised you at the beginning. One line, everything else is identical. Let's zoom out one more time. This template, fixed window frequency maps comparison, it shows up in a whole family of problems. LeetCode 567, permutation in string, fixed plus frequency, return true if any anagram exists, done in episode 5. LeetCode 438, find all anagrams, same fixed template, return every index, that's today. LeetCode 76, minimum window substring, variable window, frequency maps, done in episode 4. LeetCode 3, longest substring without repeating characters, variable window, set, done in episode 3. LeetCode 424, longest repeating character replacement, coming in episode 7. And LeetCode 1004, max consecutive ones 3, coming in episode 8. Same underlying idea, different constraints. Master the pattern once, you unlock all of them. Quick look at where we are headed. Episode 7, longest repeating character replacement, LeetCode 424. Variable window and a trick we have not seen yet. A max frequency constant that tells you when to shrink. That one is a step up. Episode 7 is the first time we use a variable window with a clever invariant. It's worth the wait. Episode 8, Max Consecutive Ones 3, LeetCode 1004. Variable window, K-flips, coming soon after. And for the record, episode 1 through 6 are done. Intro, fixed window, variable window, minimum window substring, permutation and string, find all anagrams. 6 episodes, 1 pattern, fully built. Alright, that's episode 6. 3 things I want you to live with. 1. Same fixed window from episode 5. Just collect every match instead of returning true. 2. One extra line, result.append index. That's all that changed. 3. Pattern recognition is the skill. The code is just the expression of it. If something clicked today that didn't click before, or if you have been following the whole series and it's starting to feel more like a pattern matching than memorization, that's the goal. That's the whole point. If this helped, hit the like button. It really does help the channel. Subscribe if you want episode 7. The variable window trick is genuinely interesting and I don't want you to miss it. Drop a comment if you have any questions. I read them. Learn smart, code calmly. I will see you in episode 7.